Hi, and welcome to the Stair Tailored. I'm Jessica Mao, and I'm from the University of Texas at Austin. This is the last video of a 5-part series on how to factor quadratic expressions, and this video is on how to help students establish and understand the equivalency between quadratic expressions and its factor forms. Now, before we get into it, let's talk about the foundation upon which this work is built. There are 3 primary ways of representing mathematical ideas. We have concrete, pictorial, and abstract. And at this point, we want our students to establish comfort and flexibility with working in the abstract form. The purpose of today's topic is to establish that the quadratic expression and its factor form are equivalent. And there are a lot of ways to go about showing students how to do that, but here's one of the methods that we want to demonstrate. So here we have a problem that we can pose to students, which says that the area of every classroom in the school is x squared plus 2x minus 8. Fill in the table to represent the areas of the specific classrooms. So here we have the listed x value as well as the quadratic expression. And at first, students can use this quadratic expression and to fill in the value of x to find the area of each respective classrooms. And what we're doing here is establishing that the expression is true for these x values. Now, by giving students this quadratic expression here, we're assuming that students are already comfortable and pretty proficient in multiplying linear expressions to have arrived here. And now we're going to use this expression to figure out what its factors are. For this problem, I'm going to use the box method to help me organize and make sense of the problem. So check out our last video, part 4 of this series, to look at how to use the box method to factor quadratic expressions. So now let's get started. So the first thing I'm going to do is to look at my first quadratic term, x squared, and I'm going to put it in my first product box, as well as my constant term of -8, right here. And so the first thing we're going to do to tackle is the x squared. We're going to find the factor pair of our first term, which is going to be x and x, because x times x equals x squared. Okay, I'm just making it a little stronger. Now we're going to find the factor pair of -8 we have that rule that we talked about previously, that will sum to the linear coefficient of +2. So what I'm going to do here is look at all the possible factor pairs to figure out and rule out which one will satisfy this rule. So we have 1 and -8, -1, 8, and 2, -4, as well as -2 and +4. So these are my factor pairs of -8. I'm going to go through them one by one to see which pair will give me a sum of +2. So 1 plus -8 is going to be -7, so it doesn't match. I'm going to cross it out, as well as this one because it's going to be +7. And here will give me a sum of -2 because 2 plus -4 is going to be -8. And we're looking for +2, not -2. So I'm going to cross this out. My last one is going to likely be it, and I'm going to double check. -2 plus 4 is going to be +2, which matches. So I'm going to circle this. This is my factor pair of -8, and I'm going to fill it out right here. We have -2 and +4. And +4, I'm going to write +4 right here. So now that we have the factor pair of -8, and I have these filled out, I'm going to fill out the rest, which is pretty easy because we know that we have x times x equals x squared. Now x times -2 is going to be -2x, and x times +4 is going to be 4x. And finally, we can triple check that 4 times -2 is -8, and that is true. So from this box method, not only do we figure out the factor term, we can also triple check that all of these products actually give me this expression. So we can triple check just by looking at, we have x squared, and then the next term we have, if we were to combine the like terms, we have +4, -2, which gives me +2, and that is true. And finally, we have -8 and -8, and they match. So the factor form of x squared plus 2x minus 8 is going to be x minus 2 times x plus 4. And this is my factor form of this expression. So once students have used the box method to find the factors, you can now revisit the original expression as well as the original data set or data here. And we can now fill in the answer as we can find the factor form of x squared. I'm going to write the statement or the equation right here. X squared plus 2x minus 8 equals x minus 2 times x plus 4. So this is a statement, and previously students have filled in the areas of the x value given that expression where they plug in, for example, 7 as x. Now students can do the same thing with the factor form. So if students were to use, say let's use 9. So if we were to use the x value of 9, we can we can substitute it with the x in the factor form. That's like this. So we can say 9 minus 2 times, I meant to say 9 plus 4 equals 7 times, that would be 13. And 7 times 13 is 7 times 3, 21. 7 times 10 is 70. 21 plus 70 is 91. And it checks. It matches the answer. So here, students can see that not only are these two forms equivalent, and that it can really reinforce the concept of the equal sign to really stress what equivalence means, or equivalency means. Thank you for watching this Stair Tailored. You can find additional instruction on multiplying linear expressions and other algebraic content in the Stair Tailored series.